Hi, this is Open Up Resources, Algebra 1, Unit 1, Lesson 5, Don't Break the Chain. Our learning focus today is to represent a story context using tables, graphs, and equations. We use function notation to write explicit and recursive equations. And so we're trying to look for the pattern of growth in a story and how does it appear in each of those representations. So let's look at our first, and only story for this one. Maybe you've received an email like this before. Hi, my name is Bill Waits, founder of Super Scooper Ice Cream. I am offering you a gift certificate for our signature Super Sundae. That's an $11.95 value. If you forward this letter to 10 people, when you have finished sending this letter to 10 people, a screen will pop up. It will be your Super Sundae gift certificate. Print that screen out and bring it to your local Super Scooper ice cream store. The server will bring you the most wonderful ice cream creation in the world, a Super Sundae with 3 yummy ice cream flavors and 3 toppings. This is a sales promotion to get our name out to young people around the country. We believe this project can be successful, but only with your help. Thanks for your support. Sincerely, Bill Waits, founder of Super Scooper Ice Cream. So these chain emails rely on each person who receives the email to forward it on. Have you ever wondered how many people might receive the email if the chain remains unbroken? To figure this out, assume it takes a day for the email to be opened, forwarded, and then received by the next person. So on day 1, Bill Waits starts out by sending the email to 8 of his closest friends. They each forward it to 10 people, so that on day 2, it's received by 80 people. The chain continues unbroken. So, how many people receive the email on day 7? Well, let's go ahead and write this out. So, the first day, we had 8 people. The second day, it sends out to 10 people, so that's really 8 times 10, which is 80. The third day, 80 people have it. They each send it to 10, and that's 800. The fourth day, we have 800 people sending it out to 10, so that's 8,000. Fifth day, we have 8,000 sending it out to 10, so that's 80,000. The sixth day, I'm noticing a pattern on here. We've got 1, 2, 3, 4. So I'm going to say the sixth day is going to be 5 zeros, which is 800,000, which makes day 7, 8, and 6 zeros, which is 8 million people. So it'll get out to 8 million people by day 7. So how many people have received the email on day N? Explain your answer with as many representations as possible. Okay, well, if we look up here at what was happening, each time we were timesing it by 10. So this was timesing it by 110. Here we had to times it by the 1 and 2 tens. This one would have been 3 tens. 1, 2, 3, 4 tens. 1, 2, 3, 4, 5 tens. Notice how that compares to my day number. It's 1 less. So my consistent piece here is every time we'll do people. I have 8 people and I'm timesing it by 10, but I'm not timesing it by the day number. I'm doing the day minus 1. So we actually just did our explicit equation first, just because we kind of already had the work shown up here. But let's go ahead and do our table and see how it looks from there. So if we had day and people, day 1 was 8, day 2 was 80, day 3, 800, day 4 was 8,000. All right, so I can see that my common ratio here, each time I'm timesing by 10. And if I go to a graph, it's many representations. That's usually a table, a graph, recursive, and explicit equations. So there's our table. Here's our explicit equation. Here's our graph. So we need to go, let's go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. And if I've got to get up to basically 80,000, 1, 2, 3, 4, 5, 6, 7. I don't even know how I'm going to do this. 5 is 80,000. We'll just count by 2, 3, 4, 5, 6, 7. I'm going to erase my arrow at the top here and make it just a tad taller so I can have 8. So that'll be by 10,000s. 10K, 20, 30K, 40, 50K, 60, 70K. I'm do a little shorthand since it's hard to be accurate on these on here. All right. So first day is 8. Super, super low on here. Second day is 80. That's still pretty low on my graph. Third day is 800. Still pretty low. And fourth day is 8,000. That's right about to the 10. And 5 is 80,000. Look at our, scoot that over just a tad. 5 is about 80,000. So it's really just kind of going really high up on that. Okay, recursive. So recursive function is going to be here. I'm going to start with my first term. F of 1 equals 8. And then my output, F of D, looks like we used D for our variable, is the previous F of D minus 1. And then what did I do each time? Times 10. So there's my recursive. All right. We'll go ahead and do the ready for more next, since it doesn't completely change what we're doing from there. Although offers like Bill's are usually scams, let's think about what would happen if he really did give away all the ice cream offered in the email. If Bill gives away a Super Sundae that costs him $4.95 to every person who receives the email during that first week, how much will he spend? So we really have to kind of figure out how much he's doing on this. So I'm actually going to do this in a text box. I think it's going to be a little bit easier for me. So if we do day and then emails and then money spent. Might have to scoot this over a little bit. Well, no, maybe not. Okay. So on day 1, he sends out 8 emails. And if we do 8 times $4.95, we end up with $39.60. On day 2, we end up doing 80 emails. And 80 emails ends up costing $396. Day 3 is going to be 800, and that is going to cost him $3,960. Do you see what's happening with our money over here? I bet you can. A couple more, but we can have room for here. So we've said a whole week. So we need to go to day 7. 8,000. Let's put a comma in there. All right. So that's actually going to make mine grow another 0 over here. 39, comma 600. Okay. And then 5 will be 80,000, which means it'll be 396,000. And let me just start a new table over here. Space down below. Okay, so day 6, we end up with 800,000 emails, and that adds up to 3,960,000. Honey, I think I'm still doing okay. 7 emails, 8 million. 8 million times 495 is 39,600,000. All right. And so if we go and add up all of these monies here, the 3960 and all the money he spent, because we want a total, we would end up with 43,999,995.60. So he would be out almost $44 million if everybody who got that email just in 1 week came in and asked for that discount. So he's probably hoping people get the word out and don't actually turn in their coupon. All right. So we're finding the common ratio in a geometric sequence. How does a table help us? A table helps us by dividing any output by the previous output. That's essentially what we did up here. We looked at it as a 8 times 10. We could see that, and we knew that number, and 80 times 10 was 800. 800 times 10 was 8,000. We knew that, but we could go backwards if we didn't recognize it right away and say, 8,000 divided by 800 is a 10. So that means I have to times 10 to get to the next one. So it's kind of like a reverse figuring it out. All right. Our explicit equation was, if you remember, go ahead and do this one in black, we'll do f of d, because we use d for days, and we had 8 consistently, and we had to multiply by 10 d minus 1 times. Remember, I had to do a day behind. So that made the recursive. We started with day 1. We had 8 people. And then after that, to get our number, we had to take the previous answer and times it by 10. All right. And then our graph. Let's go down here to our graph. What does our graph do? Well, we can find it by dividing any y value by the previous y value. So very similar to our table, we could have taken these. It's hard to be very accurate with where we had to jump to 80,000. So that didn't work quite as well with a graph. You could just, by the look of it, we could see it was an exponential. So that might have helped us find the common ratio. All right. Retrieval. Let's get some review. Show how to identify the rate of change in each representation. So when you have a table, what you're doing is usually a rise over run, or trying to figure out what's the change between the different pieces here. So here, 12, my first one is a -3. That's my first thought. Dividing, I know 12 doesn't divide 9 evenly, or 9 doesn't divide by 12 evenly. But if I try the -3, it works. So since that is a consistent difference, then I want to do my rise over run. And each of these are a difference of +1. So my rise is -3 over 1, which is -3. So same thing over here. Rise over run. So this one looks like it is at 12. And this one looks like it's at 9. So it's going, my rise is down 3. And it looks like it's over 1. So down 3, right 1. Which down is to the negatives, right is to the positives, which means my slope is -3. So both of these are actually showing the same thing. And so what is my rate of change on here? For both ones, -3. All right, so use the explicit equations for h of t and d of t to evaluate a through d. All right, so for a, I'm going to put 4 in. So it's the h. So I'm going to do my h's in purple. So instead of t, I'm going to put in a 4. So it's going to be not an F, it's an H. H of 4 equals 5 times 3 to the 4th. Well, 3 to the 4th is 3 times 3 is 9. 9 times 9 is 81. So that's 5 times 81, which equals 405. Okay. I'm actually just going to go ahead and do C next because that's right below it. So now I'm going to do H of 0 equals 5 times 3 to the 0 power. Well, anything to the 0 power is 1, so 5 times 1 is 5. Okay, B and D, those two have the D equations, and that's this guy. So let's go ahead and do 7 minus 9 times, instead of t, I'm going to put 2 minus 1. Well, 7 minus 9 times 2 minus 1 is 1. 7 times 9, it's a 9, is -2. So let's try D. So I'm going to do a -3 in this one here. So D of -3 equals 7 minus 9. 2 minus, not 2, -3 minus 1. So 7 minus 9 times -3 minus 1 is -4. 7 minus 9 times a -4 is 36. -36. So it's minus the -36. Double negatives make it a positive. 7 plus 36 is, 9 times 4, 3 is 27, 4 is 36. Okay, making sure I did that one right. 7 plus 36 is 43. 43. All right, thanks for joining us, and we'll see you next time.